Hello everyone, welcome to all in YourPedia Education. My name is Manish Singh and today I am going to discuss with you the second worksheet for upcoming exam, that is CGPDTM, correct, Comptroller General of Patent Design and Trademark, correct, and 2023. So this is second worksheet of strength of material. So let's see one by one. So in this worksheet again I give you some important questions from throughout the subject, correct. So this is question from obviously Excel loaded Excel analysis of the bar, and you can see the previous one, you can see again this is from same Excel analysis of the bar, and in this you can see in this question यहाँ पे क्या क्या आने वाला है, that is Excel load as well as bending load, yes or no. So this kind of some practical examples are also given here, and this is from shear stress analysis, and this is from again bending stress. Then you can see this is from again bending stress, and actually this is a practical example, correct. So many times we have seen many questions asked from practicals, not directly आपको theoretical question ना दे के वो कुछ practical approach दे देते हैं, and like you can see here in this we have a shaft which is subjected to some axial load and you need to design the shaft on the basis of bending, correct. So this is little bit different type questions, correct. And next this is again you can see this is from shear force and bending moment diagram, and again you can see here shear force bending moment में generally हम क्या करते हैं कि the beam is subjected to point load, UDL, UVL, yes or no. इन सब problems को हम लोग easily solve कर सकते हैं, but in this you can see the load variation is given here, function के form में given है, and you need to draw its shear force and bending moment diagram. So you should ready for this kind of question also, correct. And next, and you can see here the answers are also given, so you just practice it, and जो भी आंसर है आप यहाँ से मैच कर सकते हो. And this is again from shaft, you can say the shaft in series, and you can see this is again a question from shaft which is subjected to actually I can say this is a problem belongs to shaft design, yes or no. You can also design the shaft, correct. And obviously here we have two beliefs in which one is subjected to horizontal load and another one is subjected to bending load. So in this question you need to draw first load diagram, after that you need to draw its shear force and bending moment diagram, and since you have horizontal and vertical bending moment, so you can get two bending moment diagram, yes or no. और उन दोनों bending moment diagram की help से you need to find out where you get maximum bending stress, bending moment, and on the basis of that maximum bending moment you need to calculate the shear stress induced. Is it clear? And next this is a you can see generally हम लोग क्या करते हैं एक मोमेंट या दो मोमेंट लग रहे होते हैं, then we can solve the problem. Then here you have यहाँ पे जो मोमेंट लग रहा है this is a function of length, yes or no. Gradually मोमेंट act हो रहा है and you need to find out you can see this is the uniformly distributed moment, so you need to calculate bending stress, yes or no, for this kind of loading. Again you can see this is from a strain Rosette's problem, and you can see the beam is subjected to load at end, determine the maximum principal stress. Obviously this is from combined stresses chapter, in which you can see here we have two force, which is one is acting axial load and another one is transverse load. Then obviously due to transverse load here we can get direct shear stress as well as a bending stress, and this is normal stress. तो आपको क्या करना है, on the basis of this loading condition you need to draw a state of stress condition first, and once you get the state of stress then you can easily determine what is the maximum load and maximum and minimum normal load may act. And again this is an unsymmetrical type object, yes or no. You can see here that this is the triangular object whose width is varying from 0 to maximum width, but thickness is uniform, thickness is constant, and it is subjected to UDL type, uniformly distributed load. So on the basis of this you need to calculate total angle of twist at total slope at the free end as well as deflection at the free end. So again little bit this is a unique type question. Here you can see width is also varying along the load, yes or no. तो यहाँ पे आपको load का function तो load तो मिल ही रहा है, load is a function of length x and width is also a function of x, correct. And this is very simple question. Again here you need to calculate maximum deflection, yes or no. So load is acting here, so I think you need to calculate maximum deflection, yes, determine the maximum deflection of the beam, yes. So this is again unsymmetric type loading, and this is also from bending stress analysis. You need determine the equations. Here you need to calculate equation. You need to write equations for elastic curve at a different sections. And now again this is a non prismatic type member, and here the cross section is uniformly varying. So again you need to calculate the beam has shown in the tapered along width, and if it is subject to preload at free end, so you need to calculate strain energy, correct. So by using Castigliano's theorem you can determine the strain energy, as well as if you want to find deflection, then we can also determine deflection, yes or no, and slope of this beam, correct. So and this is very similar question which we already asked in the GATE exam, correct. And now you can see determine the strain energy. Yes, so here I am covering some questions from strain energy, correct. And here you also need to calculate strain energy, and yes, here you need to calculate a strain energy due to this uniformly distributed load on the cantilever beam. And now you can see here we have a simply supported beam whose cross section is looking like this. So here we need to determine how much maximum load this beam can resist before failure, correct. So and now you can see the consider rectangular steel bar of this size, and this is given. So you need to find out buckling, how much buckling load may act, yes or no, and how much stress may also induce, ये आपको calculate करना है. This is from column, and this is also a question from column. So in this series I am trying to cover the whole syllabus from simple strain, then bending, then torsion, then combined stresses, principal strains, Mohr circle, reflection, SFD, VMD, and then a column also, yes or no. So entire topic is covered with the help of these 23 questions. Around 30 questions I already solved in the classes. Upcoming जो हमारी classes चल रही है उसमें हम already solve कर चुके हैं. And dear students, if you eagerly preparing for, अगर आप sincerely prepare कर रहे हो इस एग्जाम की, तो डेफिनेटली दिस मॉड्यूल YourPedia का ये जो मॉड्यूल है ऑन CGPDTM, दिस डेफिनेटली हेल्प यू गाइस. एंड अगर आपने नॉन टेक की प्रिपरेशन स्टार्ट कर दिया, अभी टेक्निकल का आपने अभी तक डिसीजन नहीं ले पाए, तो डिसीजन क्विक डिसीजन लो, क्योंकि टाइम बहुत कम बचा हुआ है. ओनली वी हैव 2 मंथ, करेक्ट, फ्रॉम टुडे टू योर फाइनल जो मेंस एग्जाम होने वाला है, तो अप्रॉक्सीमेटली 2 मंथ का टाइम है, इवन लेस देन 2 मंथ टाइम लेफ्ट है. तो इस इतना ड्यूरेशन क्या है, बहुत कम है, करेक्ट, इस एग्जाम में. तो आपको क्या करना है कि अर्ली प्रिपरेशन स्टार्ट करनी है. आपको वेट नहीं करना है कि मेरा रिजल्ट आए, मेरा सिलेक्शन होगा तो फिर मैं प्रिपरेशन करूंगा, तब तो टाइम बहुत काफ़ी निकल चुका होगा. तो आप लोग अभी से प्रिपरेशन स्टार्ट करो, और मॉडल ऑलरेडी स्टार्ट हो चुका है. इवन 2-3 सब्जेक्ट हमने कवर भी कर दिया है, करेक्ट है. फिर भी अभी देर नहीं हुई है, फटाफट इसको आप ज्वाइन कर लो, जिससे आने वाला एग्जाम आपका डेफिनेटली बेहतर हो पाए, करेक्ट. सो दिस इज ऑल अबाउट दिस सीरीज. एंड ऐसे ही हम रेगुलर बेसिस पे और भी सब्जेक्ट्स के ये जो क्वेश्चन प्रैक्टिस सीरीज, क्वेश्चन प्रैक्टिस सीट है, ये हम प्रोवाइड करने वाले हैं आपको. कुछ हम क्वेश्चन ऑलरेडी क्लासेस में सॉल्व करा रहे हैं, और बहुत सारे क्वेश्चन ऐसे हैं जो हम आपको खुद की प्रैक्टिस के लिए यहाँ पे देने वाले हैं, करेक्ट है. और एंड वन मोर थिंग, जो डेट है वो एक्सटेंड हो चुकी है. आई थिंक आपको इन्फॉर्मेशन मिल गई होगी. जो स्टूडेंट्स अभी तक फॉर्म फिल नहीं किए हैं, तो 7 अगस्त तक आप फॉर्म फिल कर लीजिए, करेक्ट. दिस इज अनदर वन न्यूज़, करेक्ट. एंड आई थिंक दिस इज इनफ फॉर दिस. सो थैंक यू.